All right, this is Honors Algebra 2 Pre-Calc. We are doing 8.4 in Algebra 2, which is adding and subtracting rational expressions, and this is the second video in the series. So the best, or in this case, easiest to use, of the common denominator options is the least common multiple, LCM, of the two denominators. So for example, in the last video, we saw a problem where the denominators were 2 and 3. The least common multiple is 6, since they don't have any common factors, right? So in this example below, we have two denominators that have a common factor. So we should not just multiply the two denominators. We should multiply them by the factors or factor that each is missing. So for example, let's say we have 5/12 plus 1/15. So the best option is to look at the factors of 12 and 15. We see that 12 is 3 times 4, and we see that 15 is 3 times 5. They both already have a 3. So what we do is we multiply them by the factor that each one is missing. So the 4 times 3 is missing a 5, and the 5 times 3 is missing a 4. What that means is we end up getting 25 over 60 plus 4 over 60, which gives us 29 over 60. So 60 is the least common multiple of 12 and 15, right? Because if you multiply 12 5 times, you get 60. If you multiply 15 4 times, you get 60. You can still do it the way that we did it, where you just multiply by the entire denominator, but what's going to happen is it's going to give you much larger numbers, and we switch to rational functions, it's going to make your life significantly more difficult, right? So like pages and pages of work more difficult. So it's not mathematically wrong to say, hey, I'm just going to multiply the first fraction by 15 over 15 and the second fraction by 12 over 12, and then get 75 over $1.80 plus 12 over $1.80 gives me 87 over $1.80. Oh, hey, that's 29 over 60. That's not mathematically wrong. But it's going to add pages and pages of work when you're doing longer problems with rational functions. So I definitely advocate for this concept where you get the least common multiple instead of just the common multiple. So let's go ahead and walk through some examples. So we're going to fully simplify this expression. So I notice that this first denominator is an x plus 2. The second denominator is a difference of squares. This is an x plus 2 times an x minus 2. Well, that means that both denominators already have the x plus 2. So what I need is a common denominator that gives the other fraction an x minus 2 as well. So I'm going to get that this is a 3x minus 6, right, because it's 3 times the x minus 2, plus an 8, all over my nice common denominator of x plus 2 times x minus 2. So I get 3x minus 2 over x plus 2, x minus 2. Or if you want to FOIL the bottom, you can go ahead and FOIL out the difference of squares, and you get 3x minus 2, oh, sorry, plus 2, my bad, come on, brain, 3x plus 2 over x squared minus 4. My bad. Okay. So, anywho, so there we go, right? Let's look at the next one, right? So here I have an x plus 1. That's already a factor. When I factor x squared plus 2x plus 1, I get x plus 1 times another x plus 1. Right? Well, that means that I've already got one of the x plus 1s as a factor. That's great. But I'm missing the other one. I need this first fraction to have two x plus 1s in the denominator. So what's going to happen is the numerator ends up being an x squared plus x, right? Because this x gets multiplied by that, minus, and this is important, this entire binomial, this minus, goes to this entire binomial, right? That's going to matter. And on the bottom, I'm going to have an x plus 1 times another x plus 1, or if you want, you can FOIL it out. When I clean up the top, I get x squared. So this is going to be a plus x minus x, so they're gone, and then minus 2, right? On the bottom, I have x plus 1 times x plus 1. So this is a totally okay answer, right? Another totally okay answer would be if you wrote that bottom, sorry, it's a 2, if you wrote that bottom as a perfect square. Another totally acceptable answer would be if you wrote that bottom as x squared plus 2x plus 1. All of those are the same answer, right? So those are all okay answers, right? Any of them are fine. All right, so that's kind of the gist, right? So again, notice that it was important that that negative went to both of these because there's a minus in front of this fraction, which means the entire numerator has a negative in front of it. All right, so go ahead and try a P3, same idea. You can pause me if you don't want me to help. So I have this x minus 3 here. It's a solid chance that there's an x minus 3 as a factor here, and sure enough, if I check, I get an x minus 3 and an x plus 1. So I've already got the x minus 3. This fraction has an x plus 1. This one's missing the x plus 1. So we multiply by x plus 1 over x plus 1. I'm going to get 2x plus 2, right, because that 2 goes to both of them, plus a 4 over x plus 1 times x minus 3. So I get a 2x plus 6 over x plus 1, x minus 3. And that answer's totally fine. That's great. If you want to FOIL out the bottom, you certainly can. It's already FOILed out for you right here, right? If you want to factor the top, you can, right? So this is totally okay. There are also a lot of other okay answers, right? You could have had a 2 times an x plus 3 over this x plus 1, x minus 3. You could have had a 2x plus 6 over the FOILed out version, which is x squared minus 2x minus 3. Any of those are fine, right? So there's a bunch. I probably would have done this. All right, for the bottom one, I have this x minus 2. When I factor this out, I think I get an x minus 2 and another x minus 2. So one of them's already here, but this fraction is missing the other x minus 2, right? So the first fraction needs an x minus 2 over an x minus 2. So the numerator is going to be this negative 3x plus 6, right? Because the negative 3 is going to get distributed. And then notice that this minus is in front of the whole thing. So minus x minus 3 over x squared minus 4x plus 4, or the factored version, right? It doesn't matter. They're interchangeable, right? So I'm going to get negative 4x plus 3 over, and again, so that's the top. The bottom could either be an x, sorry, it's not a plus, it's a minus. The bottom could either be an x minus 2 quantity squared, or the bottom could be an x minus 2 times an x minus 2, or the bottom could be this. It doesn't matter, right? Any of those are fine. So this is okay, and having any of these other bottoms would have been fine, right? All right. So now things get a little trickier. So notice that in both E3 and P3, one of the fractions was just fine, and the other one you had to change. Well, now things are going to get slightly more complicated because now both of my denominators can be factored. So let's go ahead and factor. I'm going to do the easy one first, right? The easy one is the difference of squares. I have an x plus 3 and an x minus 3, right? And this one, I'm guessing one of those factors is going to show up, and sure enough, I get an x plus 3 and an x minus 1. So now what I want you to notice is both of these fractions already have the x plus 3. There's no incentive to multiply either of them by such a big polynomial. What I should do is multiply the second fraction by the factor it's missing, the x minus 1 over x minus 1, right? And I should multiply the first fraction by the factor it's missing, which is the x minus 3 and the x minus 3, right? So what's going to happen? I'm going to get that the numerator is a 5x minus 15 plus an x minus 1, right? Because it's the 5 times the x minus 3, hence 5x minus 15, and the 1 times the x minus 1, all over my nice happy common denominator that I am absolutely leaving factored. There is no good reason to FOIL this out, right? It's a pain in the butt. Now you could if you really want, but there's no good reason to do it. So on top, I'm going to get a 6x minus 16. On the bottom, I'm going to have an x plus 3, x minus 3, x minus 1, right? And there's my answer. I would stop there. If you really wanted, so that's great. That's where I would stop. If you really want to take a 2 out of the top, you can, but it doesn't get you anywhere, right? So the top could also be a 2 times a 3x minus 8, right? If you really wanted to FOIL out the bottom, the smart way to do it is to FOIL out the difference of squares and then FOIL this thing out. It's still not pretty, right? You're going to get an x cubed minus an x squared minus a 9x plus a 9. Like, so this is an okay denominator and this is an okay numerator, but honestly, I would just stop here. Okay, so moving on. Same idea. Now, neither of these is super easy to factor, but they're also not super hard, right? So I'm going to look at the 15 and say, okay, that's probably a 3 and a 5. And sure enough, when I see that it has the same signs and that sign is positive, that's definitely my 8, right? X plus 3, x plus 5. And so now I know I'm looking for at least one of those factors in the other one, and sure enough, the 12 is a 3 and a 4, right? I have an x plus 3 times an x plus 4, and that pans out just fine. So now I look and say, cool, they both already have the x plus 3, right? So what I need to do is multiply this fraction by the x plus 5 over x plus 5, right? And I need to multiply the other fraction by the x plus 4 over x plus 4. Right? That's what's missing. Sorry, I'm at the edge of the paper and it won't really let me write. Okay. So when I clean this up, I'm going to get a 4 times the x plus 4. And then notice that this is a minus 3. So negative 3 times the x plus 5 over that ridiculous common denominator that I see no reason to FOIL. Like, there is no incentive to FOIL this out. Just leave it as x plus 4 times x plus 3 times x plus 5. When I clean up the top, I'm going to get a 4x plus 16 minus a 3x minus 15. Right? Minus 3x minus 15. Cool. And on the bottom, I have an x plus 4 times an x plus 3. And again, you could FOIL the bottom out. I just don't see a reason under the sun to do it, right? So I'm going to get x plus 1 on the top over this thing. And if you, so the top is as simple as it's going to get, right? If you really wanted to FOIL out the bottom, you absolutely could. But this one's going to be even more problematic than the first one that I did because it doesn't have the difference of squares. So if you really wanted to FOIL this out, what I'd suggest you do is take one of the ones that's already FOILed out and then multiply it by an x plus 5, right? So if you like stubbornly wanted to make the terrible life choice to FOIL this out, I would suggest that you do it with the work that's already been FOILed out and then distribute it, but it's not a good idea. So this is like a bad life choice. It's not mathematically wrong, but there's just no reason, right? The only reason I can see to do it is if it were multiple choice and that was your option, right? If those were the answers. So I'd have an x cubed plus a 7x squared plus a 12x, and now the x's is done, are done rather, and a 5x squared plus a 35x plus a 60. And so I'd end up getting x cubed plus 12x squared plus 47x plus 60. And that would be the denominator. But again, terrible life choice. Just stick with this one, right? Okay, so you go ahead and give a P4 a try, and then that'll be it for this video, right? So go ahead and give a P4 a try. Again, I'd recommend that you factor the easy thing first, right? So the difference of squares is almost always the easier thing to factor. So once I know that I have an x plus 4 and an x minus 4, I know that I'm looking for one of those numbers here. Sure enough, I get an x minus 5 and an x plus 4. So both of them have the x plus 4 already. My job is just to multiply by what's missing. So the first fraction is missing an x minus 4 over an x minus 4. The second fraction is missing this x minus 5 over x minus 5, right? So when I clean up the numerator, right, so this is going to be a negative 2 times this x minus 4 plus a 3 times the x minus 5 all over my nice, so it just kind of came up here, all over my nice, happy common denominator. So x plus 4, x minus 4, x minus 5, right? Don't cancel things, right? Because things don't cancel at this point. Things can only cancel if everything's multiplication and division. So I get negative 2x plus 8 plus 3x minus 15 over, and honestly, I would leave the bottom like this. If you really want to FOIL it out, you can, but it's not a great call, right? There's just no reason. So I end up getting an x minus 7 over this ugly mess. And sorry, this kind of spilled into my part B, so we'll just kind of do that. Over this ugly mess. And again, in this instance, if you wanted to FOIL it out, you could a little bit more easily because of the difference of squares, right? So this is where I would stop. If you really wanted to FOIL it out, you could do x squared minus 16 times the x minus 5 and just FOIL. You'd get x cubed minus 5x squared minus 16x plus 80, right? And you could put that on the bottom too, but I wouldn't, right? All right, so last one. So I see the 16, right? I think, hey, it's probably a 2 and an 8, right? It's the same sign, so I'm pretty sure this is x minus 2, x minus 8, because that'll give me my negative 10. That also informs my decision that this is probably a 1 and an 8, because I know I probably have a common factor. Sure enough, this is an x minus 8, x plus 1, right? So both of the fractions have an x minus 8. What's missing from the first fraction is the x plus 1, so I'll multiply by x plus 1 over x plus 1. Right? What's missing from the last fraction is the x minus 2. So I multiply by x minus 2 over x minus 2. What that means is I'm going to get a 10x plus 10, right? Because the 10 times the x plus 1. And then this is actually a negative 6, right? So minus 6x plus 12 over this lovely, crazy common denominator that I should not simplify unless I'm required to do so, right? So when I clean up the top, I seem to get a 4x plus a 22. Yep, that checks out. X plus 1, x minus 2, x minus 8, right? You could factor out, like if you want, you could make the top into a 2 times a 2x plus 11, but I don't know why you would, right? This answer's fine by me. Same thing, if you really wanted to FOIL out the bottom, you could do something like you could take the x plus 1. So if you really wanted to, right, again, this is a bad life choice. But if you really stubbornly wanted to, or if you were trying to match a multiple choice answer, you could multiply the x plus 1 times the x squared minus 10x plus 16, right? And if you did that, you'd get x cubed minus 10x squared plus 16x, right? That takes care of the x. And then plus x squared minus 10x plus 16 which means that you would get x cubed minus 9x squared plus 6x plus 16, and that would also be an okay denominator. But you could do that if you wanted, right? I wouldn't, certainly wouldn't ask you to do so, and I don't think it's a great idea, but there's a plan. So that's it for 8.4.